Dear students, today I'm going to explain you about the null space of a matrix. Definition of the null space. The null space of an M by N matrix A, denoted as null A, is set of all equations to the homogeneous equation Ax is equal to 0. So the set X, we call it as a null space of a matrix. So null space of a matrix is the set of all X such that Ax is equal to 0 bar. So this is the null space of a matrix definition. Next, let A is a M by N matrix. The null space of A denoted by null A is a subspace of R power N. So we are going to show that null space is a subspace of R power N. To show that any set is a subspace, first we have to prove that zero vector is in that set, and it should satisfy closure property under addition, and it should satisfy closure property under scalar multiplication. So first we see that zero vector belongs to null A or not. By the definition of null A, you all know that what is null A. I said null A is x bar such that Ax bar is equal to 0 bar. This is the definition of null A. So null A contains the set of all vectors x such that Ax bar is equal to 0 bar. You all know that A into 0 bar is equal to 0 bar. Therefore, by the definition of null A, 0 bar belongs to null A. By the definition of null A into 0 bar is equal to 0 bar. That's why 0 bar belongs to null A. Next one is it should satisfy closure property. So you take any two vectors in null A. Let us take u bar, comma v bar belongs to null A. So closure property under addition means you have to prove that u bar plus v bar should belongs to null A. Okay, so any vector belongs to null A means what is the condition? A into that vector is equal to 0 bar. That means we have to prove that A into u bar plus v bar should be 0 bar. So what is A into u bar plus v bar? A u bar plus AV bar according to the properties of vector space. Okay, since u bar and v bar belongs to null A, by the definition of null A, AU bar is equal to 0 bar and AV bar is equal to 0 bar because u bar and v bar belongs to null A. Any vector in null A, the definition is Ax bar is equal to 0 bar. Therefore, A into u bar is 0 bar, A into v bar is 0 bar. So, A into u bar plus v bar is AU bar plus AV bar, that is 0 bar plus 0 bar, that is equal to 0 bar. Therefore, u bar plus v bar belongs to null A. So, vector addition is closed. Next, you want to prove that closure property under scalar multiplication. That means it is a closed under scalar multiplication. So, you take any vector u bar belongs to null A and C is any scalar. Scalar multiplication is closed means you have to prove that Cu bar belongs to null A. So when Cu bar belongs to null A, we can say that it is closed under scalar multiplication. Since u bar belongs to null A, Au bar is equal to 0 bar. That is the definition of null A. Okay. Next, I want to prove that Cu bar belongs to null A. So what is the definition? A into Cu bar, that is equal to C into Au bar. Because AU bar is 0 bar, C into 0 bar, that is equal to 0 bar. Therefore, by the definition of null A, Cu bar belongs to null A. So, scalar multiplication is closed, vector addition is closed, 0 bar belongs to null A. Because these three conditions are satisfied, we can say that null A is a subspace of R power n. Okay. So, here Ax bar is equal to 0 bar. A is a M by N matrix. So X should be n by 1 matrix. So because its X is a n by n matrix, so it is a subspace of R power, subset of R power n. So null space contains the set of all X such that Ax is equal to 0 bar. So X, what is X here? X is a n by 1 matrix. That's why null space is a subset of R power n and it is satisfying these three properties. So we can call it as a subspace. So null space is a subspace of R power n. Next, if any matrix A is given, how to find the null A? So to find the null A, what we have to do is we have to reduce the matrix A into echelon form and solve the homogeneous system Ax is equal to 0. Find the x. That x is called null A. Okay. So now we'll solve some example problems. See here. A 3 5 minus 5 minus 3 6 minus 2 0 minus 8 4 1. W is 1 3 minus 4. What is the question? Whether W belongs to null A or not. If really W belongs to null A, I already told you null A definition. What is the null A definition? The set of all x such that Ax is equal to 0 bar. If this definition is satisfied only, we can say that x belongs to null A. So if W belongs to null A means what? AW should be 0 bar. So multiply A into W. A into W is equal to, what is your A? 3 minus 5 minus 3, 6 minus 2, 0 minus 8, 4, 1 into 1, 3 minus 4. So multiply it here. Multiply the uh, matrix multiplication. 3 ones are 3 minus 5 into 3 minus 15. 4 threes are minus into minus plus. So 12. Next 6 ones are 6 minus 6. 0 into anything is 0. Next minus 8. 4 threes are 12 minus 4. So 15 minus 15, 0. 6 minus 6, 0. Minus 8 minus 4, minus 12 plus 12, 0. So AW is equal to 0 bar. Therefore, W belongs to null A. So if they give any vector A, if they ask you to show that W belongs to null A, what you have to do? You have to multiply the A with the W or U or whatever it may be, any vector. If the product is answer is 0 bar, then you can say that that vector belongs to null A. Okay. Next. Find the spanning set of for the null space of the matrix. So he is asking what are the matrices which spans the null space. You all know that what is null space? Null space is nothing but the set of all x such that Ax is equal to 0 bar. Okay. So here A is already given. What is your A here? A is equal to minus 3, 6 minus 1, 1 minus 7, 1 minus 2, 2, 3 minus 1, 2 minus 4, 5, 8 minus 4. It is 3 into 1, 2, 3, 4, 5 columns. 3 by 5 matrix. So your x should be 5 by 1 matrix. That is x1, x2, x3, x4, x5. So what is null space? You want to find out null space means you have to find out x such that Ax is equal to 0 bar. So like that you have to find out the x value. So for that what we have to solve the homogeneous system of equations Ax is equal to 0 bar. So for that what we will do, we will take the augmented matrix A0. So the augmented matrix A0 is equal to, what is your A? Write down your A. So your A is minus 3, minus 3, 6 minus 1, 1 minus 7. So 0 bar means we will write 0 here. And 1 minus 2, 2. 1 minus 2, 2. And 3 minus 1. 1 minus 2, 2, 3 minus 1. 0. The other one is 2 minus 4. 2 minus 4, 5. And 8 minus 4. This is 0. So this is the augmented matrix A0. Now we are going to change the echelon form. So once we'll check the matrix minus 3, 6, minus 1, 1 minus 7, 1 minus 2, 2, 3 minus 1, 2 minus 4, 5, 8 minus 4. Okay. Now I want to change it into echelon form. I'll do one thing. I will interchange the columns. So what I will get? 1 minus 2, 2, 3 minus 1, 0, and minus 3, 6, minus 1, 1, minus 7, 0, 2 minus 4, 5, 8, minus 4, 0. I have interchanged the rows R1 and R2. Next, I want to make this one 0 and this one 0 by taking the first row. So what I will do is 1 minus 2, 2, 3 minus 1, 0. Okay. Next, I will replace R2 with R2 plus 3R1. So R2 plus 3R1 means, so this is minus 3 plus 3R1. So minus 3 plus 3 is 0. 6, I'm multiplying with 3 and adding. 6 minus 6 is 0. This is minus 1 plus 6. 6 minus 1 is 5. Next, and this is 1. 3 threes are 9. 9 plus 1 is 10. This is minus 7. I am multiplying with 3. Minus 7 minus 3. That is again minus 10, 0. Okay. So 3 minus 3, 0. Minus 6 plus 6, 0. 6 minus 1, 5. 9 plus 1, 10. Minus 3 minus 7 minus 10. 0 plus 0 is 0. Now I am replacing R3 with R3 minus 2R1 because I want to make it 0. This is 2. 2 minus 2 is 0. This is minus 4. Minus of minus become plus. This is 0. This is 5. 5 minus 4, that is 1. This is 8. 8 minus 6 is 2. And this is minus 4. Minus 4 plus 2. This is minus 2. And this is 0. Okay. This is the matrix. Now, first one. 1, 1, minus 2, 2, 3, minus 1, 0. I am dividing the whole row with 5. 0, 0, 5 ones are, 5 twos are, 5 minus 2s are 0. And this is 0, 0, 1, 2, minus 2, 0. So I am replacing R2 with R2 by 5. Okay. Now you see second row and third row is exactly same. To make it echelon form, so first we have to make this 0. Next, I have to make this 0, so it is already 0. So by subtracting the third row with second row, complete third row will become 0. So we'll write here 1 minus 2, 2, 3 minus 1, 0. Next, this is 0, 0, 1, 2 minus 2, 0. This is again 0, 0, 1, 2 minus 2, 0. So I am making R3 is replaced by R2. So it become 1 minus 2, 2, 3 minus 1, 0, 0, 0, 1, 2 minus 2, 0. And this will become completely 0. So I have replaced R3 as R3 minus R2. Now it is in the echelon form. We will write the equations now. This is x1 minus 2x2 plus 2x3 plus 3x4 minus x5 is 0. Second one is x3 plus 2x4 minus 2x5 is equal to 0. So I have two equations and I have 5 unknowns. So 5 minus 2, 3 free variables are there. So I have to take x5 as k1. Let x5 as k1, x4 as k2. Then x3 will become, what is x3? X3 is equal to minus 2x4 plus 2x5. So that is minus 2k2 plus 2k1. This is your x3. And you don't know x2 value. So let us take x2 is equal to k3. So x1 is 2x2 minus 2x3 minus 3x4 plus x5. So 2 into x2 I don't know. 2x3. x3 is minus 2k2 plus 2k1. 3x4. x4 is k2 and x5 is k1. Now this is 2k3. This is minus into minus 4k2 minus 3k2. That is plus k2. This is minus 4k1 plus k1. This is minus 3k1. So this is your x1. Now you got all the values x1, x2, x3. So null A is set of all x such that. So null A is x such that. What is your x here? Your x1 is minute. So your x is x1, x2, x3, x4, x5. Okay. What is your x1? Your x1 is 2k3 plus k2 minus 3k1. Your x2 is k3. Your x3 is minus 2k2 plus 2k1. And your x4 is k2. And your x5 is k1. Take k1 common. 2k3, sorry. So 2k3 plus k2 minus 3k1. Okay. So take k1 common. This is minus 3, 0, 2, 0, 1. And your k2 is 1, 0, minus 2, 1, 0. And your k3 is 2, 1, 0, 0, 0. So these three vectors span null A. So what are the three vectors? Minus 3, 0, 2, 0, 1, comma 1, 0, minus 2, 1, 0, comma 2, 1, 0, 0, 0. These vectors spans null A. So to find out spanning set for the null space, what you have to do? You have to take the augmented matrix A0, A0, A and 0. You add just column 0 and make it into echelon form. How will you make the echelon form? Here, for to make the problem easy, I have interchanged this. And after that, I want to make these two zeros. These two columns 0. See here, this is already 0. Next, I have divided with the 5 and I have subtracted this third row with the second row. It is completely, it's become 0. Then I wrote the equation x3 plus 2x2 minus 2x3 is equal to 0. See here. So therefore x3 is equal to this and x4 is k2, x5 is k1. X2 I don't know, that's why I have taken one more variable because we have two equations and 5 variables. So 3 independent variables we will get. This one way, this is one variable, this is one variable, this is one variable. So x1 is, so this is your x1. So x1 is 2x3 plus k2 minus 3k1. So write x1, x2, x3, x4, x5. Take k1, k2, k3. Okay. So whatever vectors we will get, these vectors will spans null A. Okay. Next we'll do one more problem. Determine whether the set is a vector space and find the spanning set of W. See here, W is equal to A, B, C, D. What is the condition is given? A is equal to 2B plus 4C. So B is B only. And 2A, okay. A minus 2B is equal to 4C. 2A is equal to C plus 3D. Okay. Then we'll do one thing. We'll change B. So we'll do one thing. 1 minute. So W is equal to A, B, C, D. So see the conditions. So A minus 2B is equal to 4C. And we'll change everything into AC. Okay. So we'll write A only. And we'll change B as A minus 2B is equal to 4C. 2B is equal to A minus 4C. B is equal to A by 2 minus 2C. So A by 2 minus 2C. C we will keep C as it is. And 2A minus C is equal to 2A is equal to C plus 3D. So 3D is equal to 2A minus C. So D is equal to 2 by 3A minus C by 3. So 2 by 3A minus C by 3. So I have insert the condition here and I have taken A common 1, 0, sorry, 1, 1 by 2, sorry, 1, 1 by 2, 0 and 2 by 3. Next, if I take C common, 0 minus 2, 1 minus 1 by 3. So the spanning set of W is, what is spanning set of W? 1, 1 by 2, 0, 2 by 3, comma, 0 minus 2, 1 minus 1 by 3. These two vectors spans W. So W is a span of two vectors. What is the two vectors? 1, 1 by 2, 0 and 2 by 3. This is one vector. The other vector is 0, minus 2, 1 minus 1 by 3. These two vectors spans W. So W is a linear span of, this is suppose if you take it as UV, L of U comma V. And you all know that linear span is a subspace. Therefore, W is a subspace and it is also a vector space. Okay. You know that linear span is a subspace. So W is a span of these two vectors. This is a linear span of these two vectors. Therefore, W is a subspace and it is a vector space also. Okay. Next, determine whether set is a vector space and find the spanning set of W. Here you see 0 vector 0, 0, 0, 0 does not belongs to W. 0 vector does not belongs to W. Here, see, 0, 0, 0, 0 is equal to B minus 5D, 2B, 2D plus 1D. That means B minus 5D is 0, 2B is 0, that means B is 0, 2D plus 1 is 0, that means D is equal to minus half. Finally, D is equal to 0. So here you are getting D is equal to 0. Here in the same way you are getting D is equal to minus 1 by 2. So it is not possible. So 0 does not belongs to W. Therefore, if 0 vector does not belongs to W means it is not a vector space. So in the vector space definition, it should be a subgroup under addition. It is a group under addition. Addition means additive identity element should be there. 0 vector compulsory is there in the if it is a vector space. So 0 vector does not belongs to W. Therefore, W is not a vector space. Okay. Next. Next, you see that find the basis for null A. So you all know that what is null A? Null A is set of all equations Ax is equal to 0. See here 1, 2, 3, 4, 3 by 4 matrix. So what should be your X? 4 by 1 matrix. That's why X, Y, Z, W. Okay. Take the augmented matrix. To find the always remember null A, you have to take the augmented matrix A0. That is 1, 0, 1, 0, 3. 0, 1, minus 2, 3, minus 5, 1, 2, 4, minus 2, and 0, 0, 0. Okay. So we have to make it into, I'll explain you, taking the matrix clearly. A0 is, what is your A? 1, 0, 1, 0, minus 3, 2, 0. Next 0, 1, minus 5, 0, 1, minus 5, 4, 0. Next 3, minus 2, 1, minus 2, 3, minus 2, 1, minus 2, 0. Okay. So I want to make it into echelon form. It is already 0. I want to make it 0. How will you make it 0? Multiply the first row with 3 and subtract it. So 1, 0, minus 3, 2, 0, 0, 1, minus 5, 4, 0. Multiply with 3. 3 minus 3, 0. Minus 2, minus 0. That is minus 2. Next 1, minus of minus 3, plus 3 threes are 9. 1 plus 9, 10. Next minus 2. This is 4 twos are 8. 8 minus, this is minus 2. Multiply with 3. 3 twos are 6. 6 minus 2, that is 4. 0. See here. 0, minus 10, 2, 10, 4, 0. So here you see R3 is replaced by R3 minus 3R1. This is your R3. I am multiplying with 3 and I have subtracted. I got this. Just now I showed you. See here. 0, minus 2, 10, minus 4, 0. Now, to make it echelon form, what you have to do? I have to make this one 0. How will you make this one 0? Replace R3 by R3 plus 2R2. Multiply this with 2 and add it. Minus 2 plus 2, 0. 10 minus 10 is 0. This is 4. 2 fours are 8. 8 plus 4, that is 12. Okay, is it clear now? So, to make it echelon form, this one I have to make 0. So, multiply with 2 and add it. 2 minus 2, 0. Minus 10 plus 10, 0. 8 plus 4, 12. Okay, now make it into equations. X minus 3z plus 2w is 0. Y minus 5z plus 4w is 0. 12w is 0. 12w is 0 means w is 0. Okay, and y is equal to, this is 5z minus 4w. W is anyhow 0. So y is equal to 5z. Next, this is x is equal to 3z minus 2w. Anyhow, w is 0. So x is equal to 3z. So what is the equation you got? X is equal to 3z and y is equal to 5z and w is equal to 0. What is your x bar? X, y, z, w. Okay, x is 3z, y is 5z, z already there, w is 0. So take z common, 3, 5, 1, 0. So this vector will form a basis for null A. So basis for null A is equal to, what is the answer? 3510. So this is the procedure to find the basis for null A. What you have to do? You have to make it into echelon form and find your x. If x has two vectors, you will get two vectors in the null A. If x has only one vector is spanning the whole null A, this will form a, because it's a linearly independent vector which spans null A. Therefore, it will form a basis for null A. Okay. Thank you. So this is about null A.